Alrighty, so I said on the last daily that I was working on the one hard one that broke me several times over a couple Saturdays ago. In any case, I came up with something and I am going to restore the streak. Um, so it, yeah, oh yeah, streak restored. Um, so it's obviously not uh, optimal or uh, optimal, yeah, optimal, but it is something, and I'm gonna try explain it as best I can. Um, let me let me tidy up just a little bit here. There was a lot of stuff that I went through. A lot of stuff that I went through. Um, okay, so what I ended up doing was one, I broke it down into a lot of smaller parts. So first, since I want to know which digits are in the string and not all digits could be in the string, I went ahead and created a list of digits. This I probably did this earlier as well, and calculate the sum, the full sum. If it's odd, then it's not possible to divide into two balanced permutations of evens and odds. And then I calculate the half sum. The answer, I guess I don't actually need an answer. I sort the digits, so it's like 1, 2, 3 is going to be 1, 2, 3. These are all examples that are sorted already, but if you had a test case where it was like this, then you're going to sort it into like 0, 1, 2, 3, 0, 1, 2, 4, 5, 6, 7, 8. There's no 3s. 9. Um, and then I calculate the frequency of the digits using a counter. So this is going to give me for every digit what the frequency of that digit is, and then the num digits is the actual unique values of digits. So like here it'd be 9 because 3 is not included. Otherwise, if all 10 digits were there, then the frequency of digits would be 10. Or the num digits would be 10. And then the digit values is going to be a list of the smallest to largest digits. Although technically I don't think I need to sort this actually, but it is the smallest largest digits. N is the length of the string, or length of the number of digits. And half n is going to be half that. So like if maximally there's going to be 80 digits in the string, so half that might be 40. And then obviously if it's odd, which it can be, it'll be like if it's 9, then there's going to be 5 and 4. Half n will be 5 in this case. Although, should I have made it 4? Oh, maybe I shouldn't have made it round up. Maybe I should have made it round down. Let me double check if it should just be n. Let's see, half n plus 1 divided by 2 is going to round up. If it's 5, then I'm fine with it being 2, I think. Yeah, I think this still works with this end. And the mod is obviously the large constant that you want to use to prevent overflowing values. Okay, then you have total. So total is a array of um, how the sum of all values up to some digit. So like a if you had something like this, totals would give you like 0, because up to digit 0 there's 0. Up to digit 1 it'd be 2, so 0, 2. Up to digit 2 would be 6, because 1, 1, 2, 2 adds up to 6. Up to digit 3 would be 12, and up to digit 4 would be 20. So this is necessary because I need to quickly, I like to quickly calculate how big all my values can be. And then also similarly, the number of numbers up to a certain digit is also needed in my solution, because I again need to quickly calculate how big like each bag size is in terms of how many values are inside the bag. Oh, bags here I refer to like left bag, right bag, where left bags are basically the values on like even indices, and right bags are values on odd indices. It's the same calculation basically if you think about the permutations based on like two bags of digits versus like digits on even versus odd indices. It's basically the same. Sum by digits. Yeah, so sum by digits is the sum up to certain digits. Bag totals is the count up to certain digits. So here's the main thing. So for this dynamic programming solution, whenever you make a dynamic programming solution, in my understanding anyways, because I'm obviously not a pro at it, but there's going to be multiple dimensions, and each dimension it covers all the values or kind of possible values for that you want to track. And here the dimensions that I want to track are how many digits I've used of the digits that are present in the string, what the sum is using whatever you have, and here I'm thinking of the left sum or the even indices sums, and then the number of values, or yeah, the number of digits that I've used. I guess yeah, to be clearer. So the number of values that I've used, yeah, the number of values that I've used to add on to like the left bag. Okay, so and then given that DP matrix, if I were index for any of these three dimensions, then I'll get the number of ways to do that. So when you create the DP matrix, it's always going to be outside in. So this is going to be the outermost dimension, the secondmost dimension, and then the innermost dimension. This is almost like row and column. Rows is kind of the outer, and columns is the inner dimension. So when you construct the DP matrix, it should be from inside out. So you say that 0 is going to be the number of ways to do anything. So that's your default value. You multiply it by the number of ways you have your innermost dimension, so the number of elements in the bag, which is going to be half the n, because again the left bag is going to be half the size of the overall bag, overall string. And then for every sum, which is going to be half the sum, and then for every digit, which is going to be the number of digits. These are all +1 because the way it works is you generally will start from a given index and then you add 1 to that index to get to the next iteration. So yeah, you see +1, +1, +1 here. And kind of importantly, but sometimes you need to forget, or sometimes there's different ways that this can be approached, or is approached depending on the problem. But here, the number of ways is all 0 to start with, except that if you have done 0 digits, you have 0 sums, and you have 0 elements, then the number of ways of having that is 1, and that's necessary to kind of get the ball rolling. I also did this other thing where I had bag totals append 0 at the end. It's kind of a hack. It's just to work one of these calculations to make it correct. So for every index, I go through, for every index, so outermost is for every digit, right? So um, if I go through my digits, so for digit 0, for digit 1, digit 2, which because I want to skip over digits that are not present, I have this kind of digits values array. So for every index in that, and the digit is the value of the index. Again, that's how I initially kind of create the stuff. The frequency of the digits is something, and then for every sum and for every count of the so for every sum of bag um, and every count of the number of things I can add to that left bag. First, I calculate the right sum, which is going to be the total value of everything up to that point, subtracting what's the left sum. And that's why it's originally appended by 0, because I did this thing um, actually sum by digit starts with 0. I think there's another reason why I have bag totals appended here, but so anyways, it starts with 0. So the left sum would be something subtracted from that, but otherwise sum by digits would be something bigger. And then the left count, so let's say I start with zeros. There's going to be 2 zeros, so I could actually add 0, 1, or 2 zeros to the left bag. So for every kind of possibility there, I start by looking at the number of ways to get to this current kind of spot, this current sum, this current left count, this current index. If there's 0 ways to get to here, then continue. So pretty much it's just if it's not possible, it's not possible to get to this spot. And then and then the right count will be the bag totals up to this index minus what the left count is. Oh yeah, so yeah, this is the counter stuff. And then I decide how many items I want to put on the left side, which in turn determines how many items I put in the right side. So if there's like 2 zeros, or let's say there's 3 zeros, right? Then if I choose to put 1 0 on the left side, then I'm putting by default 2 in the right side. And then I double check to verify that this is possible, which is to say that none of the bags, either the left or the right bag, has an improper sum, too big. So if the right sum plus what I put in the right side, which is how much I put in the right side times the digit value, is bigger than half sum, then I skip. If the left sum is bigger than half sum, or if I put too many, like if again there's like 80 digits and I'm like putting like 50 digits on the left side, that's too much, then I break. The reason I did break instead of continue here is because this for loop is incrementing, and every iteration after that, every iteration after that is just a bigger number of things I put on the left side. So I know I can break that for loop. Here, I can't use the same logic because I can't break here. I just need to continue. And then here's the key, like, well, I don't know if it's key, but this is just common torques. But the number of ways that you would calculate how many ways to additionally put stuff into the left side would be the new value of things in the left side, choosing some number of them, some number of spots that you're putting on the left. So let's say that there's currently 3 things on the left side, and you're adding, let's say, some number 2's. There's 5 2's, and you're adding, like, let's say 3 2's. So because there's 3 things, then there's going to be 6 things total after you put it, and then you're choosing basically 3 of those spots to determine where you're adding those new things. So so that's the new ways to add to the left side. Any way set to right side is, again, how many you have in the right side and how many you're putting onto the right side, combination of that. And then you multiply the number of ways that you get to this spot times the number of ways that you're kind of contributing to get to the next spot, and adding it to however many ways you can get to the next spot using mod. And then finally, if you just get the very biggest, not the biggest, but the last element in this 3D matrix, the very, very last dimensional element, that'll be your answer. So this is like if I use all my digits and all my sums. My sum is my half, and the number of elements is half the number of elements. Then that's the answer. Whew. So was there any way for me to optimize this? Let me see. So this runs at 50%. 40%. Yeah, I am not going to optimize this. I spent way too long on this. Whatever. All right, summary. Yeah, I don't know if this summary is any good. I don't know if I explained anything any of this any well, but so here the summary is going to be use DP matrix with the with a workable interpretation of how to add to left right bags, or which is like even slash odd indices. So this solution used, or I guess my solution, because there's other solutions that are possible. My solution used 3D matrix, 3D dynamic programming matrix that went through all possible digits slash sums slash counts, since all three parts are needed for calculation from one count to the next count. So you need to know how many digits you use, you need to know what your sum is, and you need to know how many values there are in the bags. And I think what I was tripped up with was the fact that I wasn't fully realizing that for any given instance, or for any given state, or these three things can be considered state. For any given state, I didn't add on to it the right state. So so if I think of this as the left state, or previously I thought of basically how do I do my left side, and then once I figure out my left side, then my right side gets calculated. But I need to calculate both the left side and right side simultaneously in the ways that I'm doing it, and I can do so by actually like for any given point, I not only determine the sum of the left side, but the sum on the right side in some of the calculations, and not only the left count, but also the right count. So that, again, the number of ways that I'm doing something is not just the number of ways I'm doing it on the left side, I'm actually multiplying the number of ways I'm doing it on the right side, which I wasn't doing before, which was really bad. I don't know. This is, I don't know if I can really explain it any better than the crap I'm playing right now. Time complexity. This is O of n cubed, or I guess O of n times Oof. Um, so the number, let's say n is the length of the string. If n equals length of string, so it'd be O, it'd be O of n squared times, I feel like this is n cubed. Is the sum proportional to, if you have a certain string, so it's like the dimensions of this thing is digits in the array, which is n, the number of elements in the bag, which is based on the digits in the array, like it's half n, so that's n squared right there. And the sum of those digits, the sum of n digits, well, if each n is something up to 5, then the sum is between, yeah, the sum of n digits is, this may be n to the 4th? The sum of numbers is quadratic, right? If I have 1 plus 2 plus 3 plus 4, that's quadratic. It's like n squared divided by 2. Cannot be right. If you have 80 digits, the sum of those digits is going to be, it's going to be at most like 5 times, or not, it's at most 10 times 80. Yeah, so it's n squared. Yeah, so it's each one can be like contributing 10 to the sum, but the sum is capped by at most 10, so it's n cubed. Since n equals the number of digits, since dimensions for the DP matrix has you know, num of digits, half number of digits, which is going to be based on n divided by 2, half number of digits for count of left bag, and sum of all digits, which is proportional to 10 times n at most. So it's going to be, yeah, n times all that, so it's n cubed. Space complexity, this is going to be O of n cubed as well, to store the DP matrix. Alright, but if you guys find better solutions, then